Morning, everybody. How you doing? Who's here? Let's see who's here. Hi. How's things going? Let's just see who's here. Oh, look at that. How's everybody going on? How's it working for you? Everything going okay? Hopefully. Good. We had about 40 people send questions, so that was good. Probably not going to cover them all today, but keep working on them, and we'll do the same thing. I'll post the answers on Thursday. 40 people, we're talking, that's good. That's about 70%, so not too bad. What we're going to do is let's just answer questions. Let's just jump right into it. Take a look. The first question that people were asking about... Oh, that's me. Hold on here. That's the wrong screen. 1 second. Let's post that question up there. Not that one. I think I messed up already. Where was that screen? I have the wrong screen in there. There we go. That one. Yes. So there's the first question. Okay, first question right there. A lot of people are asking about this. This is, excuse me, 10.7 and 10.8, number 3. Okay, we'll keep it right there, and we'll go over it. 10.7 and 10.8. Oop, hit my head again. I got to move that a little higher. 10.7, 10.8, number 3. We'll start with that one. Okay, so let's take a look. Let's just try to get as many as we can done. You got an integral. You got a summation. We're doing series and sequences, so you should have your series and sequence binder ready in front of you. Add stuff to it. Let me know. I was thinking about this too. Extra, completely extra, so completely optional. But if people, what I want to do is just maybe once a week or twice a week for the next is do a little practice. Okay, I know you're doing a lot of stuff, so it's completely optional, but maybe something like I'll post a question at 1 o'clock, and you work on it for a half hour, and then maybe we could Zoom, and we could go over the question, talk to each other at 1:30, practice, uploading it and stuff like that, or just to see, let me know if that's something of interest to you. I know you're doing a lot of stuff, so it's not required, but a little practice, maybe once or twice a week, and see how that goes. Just toss a question up there. I'll post it here on Schoology and say you have, 25 minutes to do this, and then maybe we'll Zoom. Okay, we'll Zoom so we could, I don't have to do the problem. I'm talking to a cement wall here. I don't have to do the problem. I could just say, all right, who wants to try this part? Who's stuck? Like in class. Hey, you try it, and then I could, figure out where your mistakes are and stuff like that. So if that's something of interest to you, let me know. Send me an email, post it in the comments, whatever you want to do. Snea, I like you because you said I like that idea. Of course, all my ideas are good. So think about that. It's number 3. Let's go back to this one. Okay, so here's the series. Now, P is an unknown. We don't know what P. That's what we're trying to solve for. Okay, what are all positive values where this will converge? So we want to find out, when is this going to converge? Well, let's think about it. When does this converge? Okay, we start converging. We're doing ratio test. Especially a good hint, you see exponents in a polynomial, ratio test would be something that's pretty good there. Okay, so we got by limit as n approaches infinity of n plus 1 to the p. Remember, n is the variable. P could be 7. Okay, all over 4 to the n plus 1 times, so reciprocal, 4 to the n over n to the p. Okay, take a look at that. How does that look right there? There's your ratio test. Okay? And let's see what we got. So what happens here? This cancels with this. Now let's take a look at that. Let's say P could be 2. P could be 5. P could be 7. Whatever P is. Okay? So let's look at our situation here. It says A, here's our choices. P is greater than 0, between 0 and 4, and greater than 1. Okay, so let's look at a situation to try to eliminate some of them. What if P is 1/2? Okay, let's say P is 1/2. Well, let's do P negative first. Okay, well, no, there's no negatives in the region. Let's go 1/2. Okay, what do we got here? Okay, if P is square root, okay, if P is the square root, talk to me. Is this top heavy, bottom heavy, even Steven? What are we looking at right there? Okay, let's maybe make it easier. How about P is 2? If P is 2, n plus 1 squared, n squared. Okay, what if P is 2? Okay, what do we got? We got 4 on the bottom, and we got even Steven. You see that? Even Steven right there. Okay, so this converges to 1/4, which if P was 2, that would converge. Does that make sense? Let me just do it exactly. Get a different color here. P is 2, n squared. What if the problem was like this? And if P is 2, does that make sense? We just plug in a number, we get 1/4. Hey, that's even Steven. What if P is 1/2? Okay, now P is 1/2, square root of n. Okay, same situation. We got square root of n. Let me put 1/2 up there and 1/2 up there. Square root of n. Is that still top heavy, bottom heavy, even Steven? You see what I mean? Still even Steven. And so the 1/4, and does this converge by ratio test? Sure. Okay, what if P is, let's go with -3. Let me just rewrite it. What if it's -3? You see, whenever you're stuck, plug in a number. What if P is -3? So now I have 1 over, and like I just picked -3 as a number, 4 to the n. And we check ratio test again. So our ratio test would be 1 over n plus 1 cubed, 4 to the n plus 1, times, I'll flip it over, n cubed, 4 to the n all over 1. Limit. You see that? All right, do we still have even Steven? So it looks like this is still 1/4. Okay, so it looks like all real numbers are going to work. There is positive, there's no positive values. Okay, maybe that's why people are stuck. It looks to me like this choice would be all numbers would work. Did anybody check the answers online? See what the answers are up there? Maybe that's why people are confused by here. Shouldn't it be? It should be all real numbers. Let's just check the answers. We'll do that. Anybody check the answers? I'll post the answer key. Let me check here. I'll put it up here. Let's see what we got. Go to assignment. What number? This is 10.7. Here you can see. Let's move that. Take a look at. We're in this screen right here. And let's find 10.7. Here we go. Problem set. This was number 3. Let's see what they say. And scoring guide, it says greater than 0. So let's say they're saying they're using ratio test. If you could see it, it may not be that clear. They're using ratio test. So for all positive values of P by the ratio test, the series converges. So what about negative? What if it was negative? Then this would be flipped over. And you'd still get even Steven. I'm trying to think of a negative. Well, we did a negative situation, and we did get even Steven there. Yeah, let me look through that. So it's saying 0. So it's saying if negative. I'm looking right here. Why would you not get Still 1/4. So they did ratio test. So if you did ratio test, you should be okay. I'm going to look into that one a little more here because I'm thinking negatives still work. So they're going to see the answer. Well, the answer is A, is what they posted. So they said everything but negative numbers. But when we did a negative number, we got even Steven. So I'll take a look at that. Let me send out to, I could be wrong, but I'm thinking it is all real numbers. So take a look at that one. Let's go to same problem, same section, number 6. People were asking about number 6, but I'll post that up on the teacher thing and see what people say. Why wouldn't it be negative numbers? All right, how about here? Oh, did it ask for just positive values? Oh, let's look at the question. Amon, did you pick that up? Let's see. For what are all positive values? Okay, well, all numbers worked. Oh, I didn't even read the question. Look at that. I'm such a too early. No, just kidding. It says for all positive values of p, so all numbers work. Like we said, all real numbers should work, but their domain restriction is only positive values. Good catch, Harmon. Domain is only positive numbers, so we don't even have to worry about the negative numbers, so all numbers work. There's A. Good catch. Good catch. That's why it's A. Missed that one. All right, let's look at same type of problem. Let's look at number 6. For what values does this converge? People are asking about this. This is number 6. Same section, number 6. And we got the summation of n, 3 to the n over x to the n. X to the n, like that. And starting at 1, we would like to see when this converges. So again, let's set up ratio test. Okay, by ratio test, remember ratio test is the big test that they're going to use. The limit as n approaches infinity. We got n plus 1, 3 to the n plus 1, over x to the n plus 1, times, we'll flip it over, x to the n. You got to show this. Don't forget to show this. 3 to the n. There's ratio test right there. Don't forget to show that. Okay? And then let's cancel. So this cancels with that. We've done this plenty of times. That cancels with that. And look at that. We're at even Steven again. So this limit converges. Now remember how we do ratio tests. You first tell what the limit converges to. Like I said, I'm really thinking that they're going to have some type of ratio test, some type of, remember there's 2 different types. And we have some type of ratio test on the shorter one, the 15-minute one, because they got to test questions on Calc C. So we have the limit is even Steven. We have this limit as absolute value of 3 over x. You see that? And that converges when that's less than 1. Does that make sense? So if it converges when it's less than 1, well, let's see what we got. Let's do a little cross multiply. Now remember, this is under absolute value. Absolute value of 3 is 3, but the absolute value stays with the x like that. Don't forget the algebra stuff. And so when I cross multiply, I'm multiplying by a positive number. So I have 3 is less than absolute value of x. And remember, we cannot test the endpoints. The endpoints we're going to have to deal with. So I have 3 is less than absolute value of x right there. Okay, and so I look and look right there. Find the values. Do you see how D is a choice? Okay, think about the window that we're working on there. Everybody see that? That makes sense? You see how D is, you got a choice right there? It says exactly what we came up with. Maybe the thing that bothered you could have been the absolute value, maybe? Because there was a good number of people that asked about this one. So you did ratio test. You cross multiply here. You got this for now. The x is on the bottom. That's a little different. That's a little strange. But the x is still in the absolute value, so I'm not changing the inequality sign or anything because I'm not multiplying by a negative. So that's where I wind up with, and the answer is D. Let's go to, well, while we have this one up, does anybody, there was still some, but maybe one or two people, no big number. Does anybody have another one in 10.7 and 10.8 that you want to do right now? We're going to go to 10.2 and 10.5 next, if you printed them out. But does anybody have one that you would like to talk about? As you're thinking about that, let us go to. Did we say anything? Oh, number one. Let's do number one. Okay. Okay. So number one, take a look now. Don't get scared. Don't get intimidated by the harmonic series. Okay. Take a look at that. Don't get intimidated by the harmonic series there. We have the function. We have the derivative. We have the graph of g, okay, and it shows the graph of g. Okay, which of the following must be true about the series? Okay, so first of all, notice they put the -1 to the end right there. The -1 makes it an alternating series, right? Okay, -1 is an alternating series. So let's use alternating series test. Okay, so by alternating series test, step one, it is an alternating series. B of n is the function f of x. All right, do you see that? I'm going to have to enlarge it for me because I'm old. B of n is f of x. Okay, and f of x is this 2 plus cosine of x over x. And then they gave you the derivative right here. Okay, and then they gave you the graph of g of x, which notice what g of x is. G of x is the numerator up here. You see that? X squared, that's g of x. So the derivative, let's write it over here on our sheet, f of x is 2 plus cosine of x, and f prime of x, the derivative of cosine of x over x squared, is g of x, which they gave you the graph of, all over x to the fourth. You see that? Okay, so first of all, let's do the alternating series. Okay. So according to alternating series, step one, is it an alternating series? Since it said -1 to the n plus 1 times b of n, which is f of x, remember they said b of n, it is an alternating series. So we're going to use alternating series test. So now what are the three steps of alternating series? Alternating series, 2, it decreases, and 3, the limit. Okay, so let's first of all talk about decreasing. How do we know if something's decreasing? You should have your alternating series notes right in front of you. When is something decreasing? It's decreasing when the derivative is negative. Okay, well, take a look at the derivative here. The bottom is always going to be positive. G of x, the numerator, should have to always be negative. Since the bottom's positive, a negative over positive is negative. So this derivative, I look at the graph of g of x, and sometimes g of x is above the x-axis. So g of x is not always negative. You see that? So sometimes g of x is positive, sometimes g of x is negative. Well, then it's not always decreasing. So you say, since f prime of x, if this is for your response, is not always negative, the summation b sub n is not always decreasing. So it should be a choice that says it's not an alternating series test, cannot be determined because the series is not alternating. No, the series is alternating. The alternating series cannot be determined because the limit is not equal to 0. We haven't even gotten to that one yet. Okay, and I believe the limit would be 0 since it's bottom heavy. The alternating series cannot be determined because b of x is not always decreasing. There's D. I would think the answer would be D here. Take a look. The answer should be D. Did that make sense to everybody? Okay, here's where you got to say something. If you're stuck on it, the answer should be D because it's not always decreasing. I looked at the graph, and the observation of that one is you needed to notice that the numerator is g of x, the graph that they're giving you. All right, let's go to, did that make sense? Let's go to the first one. A couple of people are asking about the first one, number 9. Let's start there. Let's look at the first one all the way at the bottom, number 9. Everybody get that one out right there. It kind of, again, bad formatting, but we can handle it. Okay? So consider the infinite series. Let's put it over here. Consider the infinite series. We had the summation n equal, and remember, looking to me like a lot of these sections are all about alternating series. So you should have all your alternating series stuff ready to go. Make sure you understand all about alternating series. And the 1 over 3 natural log of 3 minus 1 over 4 natural log of 4 plus 1 over 5. You see how it's alternating natural log of 5, etc., etc., etc. Okay? And so it's an alternating series. So it says, consider the series, does it converge? Okay, let's see if identify the properties that the series guarantees the series converges. All right, what's the properties? Since it's an alternating series, so 1, like we were just doing, alternating series. Since it's an alternating series, let's see if it's decreasing. Okay, let's see, we got 1 over n natural log of n. Let's see if it's decreasing. Remember, decreasing past 3. Okay, so let's take this derivative. I'm going to use quotient rule here. Low, d high. Oh, look, the derivative of the top is 0. Minus high, d low. All right, what's the derivative of the bottom? Derivative of the bottom, we got a product right here. Okay, we got a little product here. Derivative of the first times the second. Okay, plus derivative of the second times the first. You see that? All over the bottom squared. Well, the bottom squared is always going to be positive because it's squared. This is always going to be 0. So really, we only have to worry about, talk to me about natural log of n. Remember, let me just do the 0 minus natural log of n plus 1 all over something squared. There's the derivative. I should have used a bigger piece of paper here. Okay, so the top, natural log of n plus 1. Okay, talk to me about natural log of n. Is natural log of n always going to be positive? Well, when does it start? Remember, natural log of e is 1. Natural log of anything past that is positive. Okay, so this whole thing inside here is positive. So a negative times a positive, negative on top, positive on the bottom. This derivative is always negative, so this is decreasing. Now, you didn't have to do all that if it was a multiple choice. Since, take a look. I got 3, 4, 5, 6. That looks like it's decreasing to me. You could even make the statement 1 over n natural log of n is always bigger than 1 over the next term, n plus 1 natural log of n plus 1. So this is decreasing. And you could have taken the derivative to see that. Let me get a better sheet of paper here. All right, now what's the limit? The third step is the limit. We didn't talk about this yet. As n approaches infinity, take a look at the limit. That's the third step. Talk to me about the limit. Oh yeah, that limit is approaching 0. So since it's an alternating series that's decreasing, whose limit approach 0, that should be in your binder right there. You should be able to just repeat that. This series converges. Okay, now explain why the sum of the series is less than 1/3. Okay, now that's kind of tricky purely because you have to remember the very first thing we talked about alternating series. Okay, remember we were talking about the sum we had, I think it was, we had 1/2 and minus 1/4 plus 1/8 minus 1/16. And we said the thing about alternating series is not that the sign is alternating. The thing about alternating series is the actual sum, right there in the middle, it alternates from one side of the sum to the other side of the sum. Okay, so for example, this sum, notice what this is. This is 1 over 2 to the n. And it's geometric. And so we know that geometric series converges because it's 1/2. Remember, geometric, it's 1/2 right there. And this converges to the first term over a 1 minus the common ratio. Everybody remember that? Everybody okay? So this converges to, first term, the common ratio, this converges to 1, right? Am I doing that right? Hold on, that shouldn't converge to 1. I did something wrong here. This is just an example. This is geometric. Is this geometric 2 to the n, right? And so it's 1/2 to the n. The first term is 1. Oh, I'm sorry. The common ratio is -1/2. My fault. So the common ratio is -1/2. And so this converges, because it shouldn't converge to 1. This converges to, that's -1/2. 2/3. So it converges to 1/3. That's better. Converges to 1/3. Okay, so the point we're making right there is the common ratio, the sum of the first term is 1/2. Here's the actual sum of the series. And when we first talked about alternating series, remember the sum alternates from one side to the other. So the sum of the first term is 1/2. That's bigger than 1/3. The sum of the first two terms is 1/4. That's less than 1/3. The sum of the first three terms is, if this is 1/4, 2/4, 3/8. 3/8 is bigger than. You see how it alternates? Here's the sum of the first term, then it goes to this side, the sum of the first two terms, then it goes to this side. That's what they mean by alternating series. Okay, take a look at your notes from that. The alternating series, the sign alternates, but that's not a deeper understanding. An alternating series bounces back and forth from the sum. So what they're trying to say on this problem is they explain why. We know the actual sum has to be between the first term, and what was first term? 1/3 natural log of 3, and the first two terms, whatever, we'll get a calculator out, minus 1/4 natural log of 4. Everybody see that? This is the first term, and this is the second term. So the actual sum has to be between, this is the first and the second term. Okay, it has to be between, it alternates back and forth between these two sums. You see what I mean? So the sum has to be between the sum of the first term and the sum of the first two terms. Well, what do we know about this? Well, all I know is this is definitely less than 1/3. So I know the actual sum has to be less than 1/3. That's all that you could really do on something like this. Since it's an alternating series, the actual sum has to be between any two terms. And since this one is positive, then it goes backwards. Well, that's the bigger one. Okay. This was multiple choice. No, it just fell that in. So you'd have to explain that. That one point for explaining the alternating series, the 3 steps in alternating series. Why is the sum less than 1/3? Because of that. Okay, so that was kind of a weird one there. Others. Is there any more on this one? The rest of them were just maybe 1 or 2 people asked about that. Anybody else have one for this sheet before we go on to the next one? 10.2 and 10.5. Are we doing okay there? Number 2? Let's look at number 2 here. All right, number 2. Notice it said with calculator right there. Okay, it wants f of 1. Okay, it wants f of 1. So f of 1 is the summation, and I'm going to plug in 1 for x. So of sine squared of 1 to the k, where k is 1 to infinity. Okay, you see that's first. It's just, there's the function f of x. It's asking for f of 1. Now, what type of series is this? Is this a geometric series? Remember, we had our nice little plan, and some of those plans are not included. The biggies are going to be ratio tests. Think about our tier 1, tier 2, tier 3. They did mention in the objectives, they mentioned geometric series. They mentioned nth term tests. I'm sorry, they mentioned geometric series. They mentioned P series and alternating series. That was tier 1. Okay, do you recognize it as one of those? And then tier 2 was nth term test and ratio test. And they mentioned that, but they didn't mention all those comparisons and stuff like that, so maybe we'll get a break with those. You never know. Okay, is this geometric? Yeah, this is geometric. Since this is geometric, notice, well, how do I know it's recognized as geometric? The k is only in the exponent. Since this is geometric, this must converge to the first term, sine of 1, all over 1 minus the common ratio. And since they said it's with calculator, I'm going to get my calculator out. Make sure, I'll check my mode because we were out of mode. Okay, my mode. So I got sine of 1 squared. There's the numerator. And I'm going to divide that by 1. Let's put in parentheses. 1 minus that. And I get 2.42. Which is 2.426. So that looks like the answer is D. You see, you got to recognize this is geometric. Jackie, did that make sense? Think about this as a geometric series. You got to think through like that. Okay, let's move on to just another one. Let's go to the last one, just to cover a couple on that one. On the last one, people were asking about number 6. That was the most question. All right, so here. All right, number 6, we got a function here. Oh, we could do 6 and 7 right there. Okay, 6 said we have, let me make sure that it's not Taylor polynomial. No, that's for those. So a function satisfies the equation, and let's take a look at it. Sorry, I gotta make it a little bigger for old Mr. Noah's eyes. We got f prime. So here's 6. F prime. Oh, a little recursion here. F of x plus 1. And then they said f of 0 is equal to 2. Okay? And for part 6, it said find a 4th degree Taylor polynomial. All right, remember that. How do we build a 4th degree Taylor polynomial? Centered at 0. Okay, here's a good review. So right away, the first thing I'm going to write is f of 0, x to the 0 over 0 factorial. I'm going to write this out, f prime of 0, just so I don't forget stuff. Double prime at 0, x squared over 2 factorial. You see what I mean? It's maybe going to need all these, but a 4th degree polynomial goes to x to the 4th. X to the 4th over 4 factorial. You see what I mean? A 4th degree polynomial goes to x to the 4th. I should have planned that a little better. All right, so now all we got to do is plug in the numbers. How are we going to get f of 0? Oh, look, they told me f of 0. So the first term is 2. A 4th degree Taylor polynomial is 2. Now, the derivative at 0. So the derivative at 0, let me go off to the side here. F prime of 0, I'll put it down here. F prime of 0 is equal to f of 0 plus x is 0, right? We're plugging in the function, right? I'm plugging in 0 for x plus 1. Okay, so let's see what we got. F is 2 plus 0 plus 1, so 3. 3x to the 1st over 1 factorial. You see how I did that? I'm just plugging in. Okay, there's the first derivative. Let's see what the second derivative is. How do I find the second derivative? Okay, I got to take the derivative. Okay, second derivative. Remember, you take the derivative first. Let me get a sheet of paper here. You take the derivative first. Okay, the second derivative is f prime of x plus 1 plus 0. There's the second derivative. And f double prime, let me put up to say, f double prime of 0 is equal to f prime of 0 plus 1. We just did f prime of 0. That's why I said recursion. F prime of 0 is equal to 3. So this must be 4x squared over 2 factorial. You see how I'm doing that? I'm just taking a derivative. There's the function. And the third derivative, we need the third derivative. So lucky by this time, the third derivative, all it is the second derivative. And the fourth derivative is the third derivative. You see? So the third derivative is the second derivative. The second derivative was 4. The fourth derivative is the third derivative, which is the second derivative, which was 4. So we've got a nice little pattern there. Plus 4x to the third over 3 factorial plus 4x to the fourth over 4 factorial. Okay? So there is, and we could simplify it, there is a fourth degree Taylor polynomial, and then you would take a picture of that and submit it to there. Maybe clean it up if you want, if you're going to use it. 7, since we're on the same subject, find the second derivative at 0 and find a second degree Taylor polynomial. Oh, well, that's kind of nice because, covered up, there's a second derivative. You see, remember how that was always including the previous ones in there. So there's number 7. That was the one, but while we're on this one, does anybody have one that we should talk about on this one? All right, so here's what we could do, unless while I'm watching here. If anybody still has one on this, then you still got a couple days, today, tomorrow, and Wednesday and Friday. Here's the plan. Let's try this, completely up to you. Let's go, and I'll post this on Schoology also. Let's say on Thursday. Okay, now the timing, here's what's going on. I teach now, and then Mrs. No and I both teach our kids after we're done here with my classes, and then she starts teach. So I usually finish there around 9:30, and then we teach our kids until about 12. Then she does Zoom. So let's say, here's what we're going to do. Let's say we're going to practice at 1 o'clock. So this will be Thursday. Okay, so let's just take a shot and see how many people actually participate. Okay, completely optional, and I'll post it on Schoology. So let's say at Thursday at 1 p.m., I'm going to post a problem on Schoology. Okay, and then you'll get prepared for it, and then you'll do the problem. And then at 1:30 p.m., we're going to Zoom. I'll have the codes in there, and then we're going to Zoom, and then I'm going to call on you. I'm not going to do the problem for you. I'll call on you and say, hey, here's what I want you to do. Do this problem, try this, work on this. Okay? Let's just do test. I don't know if it helps, it helps. If it doesn't, it doesn't. But just try something different. I know that school, they don't want us to meet, don't want to stress you guys out and stuff like that. But the AP's getting close, so let us make sure we prepare for it. So I got a couple questions, and then we'll do it that way. Then we'll try that and see what happens. If it works, it works. If it doesn't, it doesn't. We'll try it on Thursday, okay? And I'll post that in Schoology also. So your job for the rest of the day and tomorrow. Now, tomorrow the assignments also. Tomorrow I'm going to post the answers, and all you got to do tomorrow is look at the answers and check your work. And then Friday morning, like you always, we'll answer questions on if you couldn't understand what the answers were saying. We'll answer those questions on Friday morning. Okay? All right, so if you were here now, great. If you're watching the stream later, great. Make sure you watch the whole stream because that is what we'll try, and I'll try to post a problem up there. All right? All right, hopefully everybody has I saw, in case we can't start at 1. I'll post. I will. I just picked 1 because that's when our AP test is. Our AP test is at 1. But I will. How about I will? Let's see what we can do. The question will be there on Schoology. Yeah, and then we'll go through it together on Zoom, and then I'll post the answers on Schoology also after we're all done. And then therefore you'll have the question and the answers and try it out. It was just I wanted to see, how the time frame. Here's a question, work through it, and hit the buzzer, say I'm uploading it now, and then we'll get all together. So yeah, everybody has to actually shower and to be on camera. You can't just be in your PJs. Well, I'm in my PJs. So anybody else have any questions? All right, I will see you Friday for sure. And then Thursday we'll do a little test to see what happens. Okay? Have a good day, everybody.